Hi everyone, this is Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. And in this video, we are going to see about various biasing methods involved in MOSFET. So first, what is biasing means? Biasing is nothing but establishing the desired DC voltage and currents for the required operation of a MOS transistor. So the required DC voltage is VDS and the required current is drain current ID. So next we are going to see about the MOSFET's regions of operation. So just look at the figure. Actually the MOSFETs can be operated under three regions. So one is cutoff region, then triode region, and the third one is saturation region. Now just look at the cutoff region. So this is the region when VGS voltage is less than VT voltage, and at this condition there is no conductive channel present between the source and drain terminals, and therefore the resultant current ID is equal to 0. And since there is no current, the device does not conduct, and this condition is said to be cutoff region. And next consider the case of triode region. So under this region the voltage VGS should be less than VT and the voltage VDS should be less than VDS saturation. So the device is in triode region of operation. Now come to the saturation region. So under saturation region again VGS less than VT but VDS is greater than VDS saturation. So the device is said to be in the saturation region of operation. Since the drain end channel density has become small, the current is much less depending upon the voltage VDS, but it still depend on VGS since increased VGS, still the VGS voltage is increasing in the inversion layer density. So next we are going to see about common ways of biasing in MOSFETs. There are three types of biasings available. First one is biasing by fixing VGS, then biasing by fixing VG and connecting a resistor in the source, and the third one is biasing using a drain to gate feedback resistor. So just look at the circuit. This method is called as fixing VGS circuit. That's the first method. So the MOSFET consists of three terminals, the drain, gate and source. So here the voltage VDD is connected to the drain terminal and the input voltage VGS is applied to the gate terminal and the source is connected to the ground. So the objective of biasing is to keep the stable Q point. So the Q point will be stable only when we are having proper drain current ID and the voltage VDS. The values of these two parameters should not vary with respect to the device parameters such as mu n, Cox, W by L ratio and the threshold voltage Vt. So the general equation of drain current ID of the MOSFET is 0.5 mu n Cox W by L into VGS minus Vt the whole square, where W represents width of the channel, L represents length of the channel, mu n represents mobility of electrons in the conduction channel, and Cox represents capacitance of oxide layer, and finally Vt represents the threshold voltage. Actually this method is not desirable one because the parameters mu n, Cox and W by L and Vt are drastically changed due to the changes in temperature. So this is not practically used. Now consider the figure which shows the difference in performance provided by two different MOSFETs of the same manufacturer. Okay. So just let us consider the same supplier is providing two MOSFETs. So when we are operating the two devices under same conditions, we will have different drain currents. So that is represented in this figure. So the next type of circuit we are going to consider is fixed VG circuit. So here we are providing biasing by fixing the VG value and we are connecting a resistance in the source. So in the previous circuit the source terminal is directly connected to ground, but here instead we are connecting a source resistance RS. So in this biasing technique a suitable voltage VG is applied to the gate by connecting RS between source and ground. So just consider the intersection of ID and VGS. So in the y-axis we are having ID and in the x-axis we are having VGS, and the intersection curve here provides the coordinates ID and VGS, and that provides the bias point. So here it is observed that as in the case of fixed VGS, the variation of ID is much similar. So the same manufacturer's two devices will have different performance. So it shows the non-linearity of two devices. So the last method of biasing is using a drain to gate feedback resistor. So now look at the figure carefully. So here the biasing is provided by connecting a feedback resistor between the gate and the drain. So if the drain current ID increases due to any reason, maybe it is due to the temperature variations, then VGS must decrease. The decrease in VGS in turn causes a decrease in ID. So thus a negative feedback or a degeneration provided by RG works to keep the value of ID as constant as possible. So a simplified and effective biasing arrangement utilizing a feedback resistor connected between the drain and gate. So this is the most practically used method of biasing in MOSFETs. And one more thing is here the value of Rg is chosen in the range of mega ohms, so that we can keep the gate voltage to be 0.